Now we're going to talk about quadratic transformations. And quadratic transformations in math, when I say a transformation, I mean a stretch or shrink, like a dilation, a translation where it slides left or right, just a change in the shape of a graph, or the shape or the movement of a graph. So let's start off with our parent function, y equals x squared. Now I have it graphed on Desmos. It's a parabola centered at this point 0, 0. And if we want to see some points for it, we can put some up here. So it includes the points -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. It also includes the points -3, 9, and +3, 9. Now, I'm not concerned with it being perfect, but those are some points to give you an idea of the shape. I'm going to draw that same graph with my regular pencil 7 times. So 7 times I'm going to draw this same graph on all of the 7 graphs that I have. I'm going to use this as a guide graph for the rest of them. So go ahead and pause and draw those 7 graphs that look like this. Okay, you should have 7 of the same graph. They don't have to be perfectly exactly the same, but we're going for the same shape about on all 7 of those graphs. And you can see I have them all graphed in regular pencil. Now I'm going to pick up my color pencil and work with what we call a transformation. So when we change the equation of the graph, we change the shape of it, or we change where it's placed. What we're going to do is explore how the graph changes when we change the equation. So the first thing I want to graph using my graphing calculator is I'm going to graph y equals 4x squared. And on your graph paper, go ahead and write down y equals 4x squared with color pencil or a color pen, okay? So on my graph with Desmos, I'm going to leave y equals x squared at the top and do a new line and graph y equals 4x squared. There we are. And you can see that 4x squared is skinnier than the original. So I'm going to draw an example on my paper to show that this new graph is skinnier. So the new one is inside the old one. Okay, and I'm going to keep moving. The next one I want to graph is y equals 1 over 4x squared. And again, write that on your graph paper with your color pencil. And I'm going to go to Desmos and erase this, erase the second one, and rewrite it as 1 over 4x squared. And if you notice, the new one now is even wider than that original graph, than our parent graph. So I'm going to draw it on my graph paper. It's wider, draw it wider out here. That's a dilation when it gets squished or widened. And now I want you to graph the rest of these on your paper. So on your graph paper, I want you to graph y equals x plus 2 in parentheses squared. We're going to also do y equals x minus 2 in parentheses squared. We're going to graph y equals, no parentheses, x squared plus 2 without parentheses, and y equals x squared minus 2 without parentheses. And our last graph would be y equals negative x squared. So pause your video and graph those. At this point, you should have graphed all 7 of those, and you should be getting a picture of what happens as we change the equation for our quadratic function. So, for example, when we multiplied times a number bigger than 1, it got skinnier. A number that was a fraction, it got wider. X plus 2 in parentheses, actually moves the graph to the left. I actually drew this the wrong way and switched those. So let me change that very briefly. All right, so we all make mistakes. So x plus 2 moves my graph to the left. So you can kind of see my vertex is centered to the left a bit. X minus 2 moves it over to the right 2 units. X squared plus 2 moves my graph up by 2 units. X squared minus 2 moves my graph down by 2 units. And when we multiply by a negative, it reflects the graph. It flips it over the x-axis. So these changes work with other things besides just these specific numbers. Plus 2, it could have been plus 5. It could have been plus 170. So let's write down some general rules as we finish up our notes, and we'll be able to use these to solve problems and see some patterns. Now, in your notebook, we're going to have our heading, quadratic transformations. And then we're going to draw a table. It's going to be a table, I think, with about 8 different changes that we're looking at. That's not a straight line, but it'll be okay. The heading for the left side is going to be equation change. And the heading on the right side will be the graph change. Now, let's fill in this table. Okay, so here's our table. You want to copy this down. So first, our parent function, y equals x squared. So the graph change, there's no change. This is the original that we're comparing all the other graphs to. When we multiply something times x squared, if that number was bigger than 1, for example, when we did y equals 4x squared, the graph gets narrower. If we multiply by something that's less than 1, something between 1 and 0, something that's a fraction or a decimal, then the graph gets wider. Now, this doesn't mean that the graph gets wider when you multiply by a negative 0.5, or rather negative 0.5, or a negative 7 doesn't necessarily get wider. But we can have combinations of these transformations too, and you can see that with some practice. So next, y equals negative x squared. When we multiply by a negative, that reflects our graph. When we add something to x inside parentheses, it translates or slides our graph to the left. And when we subtract something from x inside parentheses, it slides our graph to the right. It's a translation right. Y equals x squared plus something that's not inside parentheses, our graph moves up. And when you subtract something that's not inside parentheses with x, it translates our graph down. So those are the basics. You want to have this table and then also take your graphs and attach them, glue them, staple them into your notebook with this table.